Let's get ready to rock some more adding fractions. So take a look at these three problems. How are they similar? How are they different? Well, we can see they're all addition problems. We like addition. It's pretty friendly. And something else I'm noticing about how they're all similar, they all have mixed numbers. They all have a whole number and a fraction in them. But how are they different? There's a few differences. So look at problem A. Problem A has fifths and fifths. So the denominators match. So I'm going to say the units. The units match. We're using fifths for both parts of that problem. Especially when I look over here. Look at problem B. Fifths, halves. So the units don't match. Units don't match. And then over here, not only do the units not match, but 4/5. 4/5 is pretty close to 1. And then you've got a half. So these units don't match. And if I add those fractions together, they're going to be greater than 1. So units don't match. Fractions are greater than 1. Scrolling down here. So we're going to start off with 2 1/5 plus 1 1/2. Now I want you to look down here. So check out this problem and the steps that we maybe could use to solve it. So take a look at this equation and take a look at all these steps. Are those true? Or another way to think of it is 2 1/5 plus 1 1/2 the same as 2 plus 1/5 plus 1 plus 1/2? Does that work in math? So go ahead and make your prediction. Is this true? Yes or no? Go ahead and pause this video, write down your prediction, and raise your hand, and I'm going to come take a look. All right, now that you've paused this video, and I've already come and approved, we're going to move on to the next piece. So what could be done to add 1/5 and 1/2? Because we never add fractions that don't match. And since they don't match, we must make them match. Make them match. Exclamation, exclamation, exclamation. Duh. And 5, well, 2 can't go into 5, but hey, they could both go into 10. So you go ahead and write out the equation for converting them into tenths. Go ahead and pause me and raise your hand to make sure you have that multiplication sentence all nice for converting 1/5 into tenths. So go ahead and write down how to convert 1/5 and 1/2 into tenths. And once you finish both of those, raise your hand and come check it with me before you move on. Now that I've approved your awesome multiplication sentences, go ahead and write the whole thing out with new units. So write our addition back with the tenths. We're speaking tenths here. And then the last piece for problem number 1. So check out the equations over here. So I want you to explain the logic, explain what's going on there. So you're going to write it out like this. Step 1, step 2, step 3, step 4. So go ahead and pause this video and write out those steps and then raise your hand to make sure that you're on the right track. Check out problem 2. This looks a lot like our first problem because we still have fifths, we still have halves, but this time instead of 1/5, we've got 4/5. Oh, 4/5 from 1 plus 1/2. I'm pretty sure that that's going to go over 1. So that's going to make it a little trickier. Because it's going to be a little trickier, I want you to go ahead and model this problem on the number line. I'll help you with this number line. So we're going to start at 0, where all good number lines begin life. And then we're going to go 1, 2, 3, 4, 5. And of course we're going to label, because nothing is happy if it doesn't have a label. And I want you to finish the rest. So you model this problem for me. So you know what that means, folks? Stop this video, model this problem on a number line, and you can even go ahead and solve it down here. Raise your hand, and real Miss Parker will come check your work. Problem number 3 is going to ask us to do a little bit of thinking before we really get started. So 2 2/3 plus 5 2/5. What two numbers is the sum going to be between? Well, let's see. 2 plus 5 is 7. Okay, so I know it's at least going to be greater than 7. But then 2/3 plus 2/5, that's going to be bigger than 1. So I need to, so it's going to be bigger than 8. But still probably smaller than 9. All right, let's check it out and see if I'm right. So 2 plus 5 plus 2/3 plus 2/5. Well, I already know that these guys would equal 7, so I'm gonna put my 7 over here, and I'm gonna just erase these suckers to concentrate on the fractions that I'm working on. Erase, erase, erase. Be gone. So 2/3 plus 2/5. Well, they don't match, so you know I've got to change them. So let's see. 3 and 5, well, those can both go into 15. So times 5 equal. So I'm going to transfer my thirds over to 15ths first. So now I have 10 15ths. And then for my fifths, I'm going to have 6 15ths. So 10 15ths plus 6 15ths, 16 15ths. Whoa. Numerator bigger than my denominator? Not cool. So I know that really this is going to be 1 and 1/15. But hold on, is that my final answer? Nope. Because remember, I had this guy up here. So I still have 7 plus 1 and 1/15 for a whopping total 8 and 1/15, which is between 8 and 9, like I originally estimated. All right, I'd like you to go ahead and write this problem out on the number line. And don't pause the video just yet. We're gonna go through problems 3 and 4, and then you can raise your hand and I'll come check them both at the same time. So let's scroll down and take a look. So what two numbers will the sum be between? Well, I know 3 and 6 is 9, but 5/7 and 2/3, that's gonna put us up over 1. So it's gonna be greater than 10 and probably less than 11. So let's take a look. So I've got, my 3 plus 6 equals 9. And let's set that aside right now and focus on our 5/7 plus 2/3. 7ths and thirds, that's a little awkward. The only thing I can think of that they would go well together with would be 21sts. So let's turn 5/7 into 21sts. 7 times 3 is how we would get 21. So we did it to the bottom, got to do it to the top. 15 21sts. All right, how about those thirds? 2/3. Now to make thirds into 21st, we're multiplying by 7. Did it to the bottom, got to do it to the top. 2 times 7 is 14. So 14 21sts plus 15 21sts is going to be 29 21sts. There's an ugly improper fraction. So I know that really, since 21 21st would be 1, I'm going to take 21 of them out. So I'm left with 1 and 8 21sts. But wait, I've got to remember, I can't forget about this 9 I put over there from my 3 and my 6. So 9 plus 1 is going to be 10. So I've really got 10 and 8 21sts. Go ahead and model this one on the number line. Once you're done, raise your hand and I'll come take a look at your work on problem 3 and problem 4. Okay, problem number 5. So check it out. We've got halves and we got eighths. Now I know you want to make them 16ths. You want to so badly, but don't fall for it. Because why make them into 16ths when we can just make them into eighths? So go ahead, do it. turn 1/2 into eighths. I bet you could do that one in your head. Psst, it's 4/8. I'm going to make us a little note right there, 4/8. All right, so now that I gave you a big fat hint, go ahead and estimate. Okay, give yourself a sec. So I'm going to sit here and wait while you estimate what numbers it's going to be between, and then you'll be able to check your guess. So if you estimated it's between 8 and 9, then you are on the right track. Okay, let's go ahead and solve. Hey, I already told you that 1/2 equals 4/8. So we've got our 3 plus our 4, and then we've got our 4/8 plus 7/8. So let's add everything together. Well, this is 11/8. Ugh, improper fractions. You know how they upset me. So really, 1 3/8 plus our 3 and our 4 up here for a whopping total of 8 3/8. Now, I know you wanted to turn it into 16ths. You wanted it to so badly. Could it be solved using 16 as the denominator? Sure it could. Go ahead and try it. Hey,